everyone. My name is Aditi Arora, Assistant Professor, CEC Department, ABES Engineering College, Ghaziabad. So in today's lecture, we will be discussing about the concept of K-map, which comes under the unit Boolean algebra in discrete mathematics. Now, what is a K-map? There was a scientist named Carnot. He introduced the concept of K-map. Now we all know what are Boolean expressions, what is Boolean algebra, and how to solve or minimize a given Boolean expression. Now, one way to minimize the Boolean expression is to use Boolean identities, or we can say theorems or laws. So there is another way of simplifying or minimizing a Boolean expression, that is K-map, right? So coming to the definition of K-map, it is a method to simplify a Boolean expression in the pictorial format without using any Boolean algebra laws, or we can say theorems, or we can say identities that you have studied, that is associative law, commutative law, idempotent law, right, involution law, absorption law. All these are the identities that we have already studied in the Boolean algebra. Now, for a Boolean expression consisting of n variables, the number of cells required in K-map is 2 raised to the power n. Now understand this point. Like if we have a Boolean function comprising of only 2 variables, we can create 4 cells in the K-map, right? 2 raised to the power 2, that is 4 cells will be there. This box is called as a cell, right? These are 4 cells of the K-map, and here we write the variable A and here we write the variable B. Similarly, if we have a Boolean expression having 3 variables, now how we will create a 3 variable K-map? So 3 variable K-map will be 2 raised to the power 3 having 8 cells, right? So here we have our 8 cells. Now here we can write the first variable and here we can write the other 2 variables, right? So you can see we have total 8 cells. Similarly, if we have a 4 variable K-map, so this will be the pictorial representation of a 4 variable K-map comprising of 16 cells. And we can write here A, B and C, D, right? Now here A can take the value 0 or 1, B can also take the value 0, 1. A can take the value 0 and 1. Now what about the values of B and C here? Coming to the third point, that K map is based on gray code, that is unit distance code. Now what is a gray code or a unit distance code? Let us understand. Initially, suppose we have 2 variables A, B. So what all can be the values? 0, 0, 0, 1, 1, 0 and 1, 1. In decimal, this is 0, this is 1, this is 2 and this is 3. Now you can see here only 1 bit is flipping. 0 remains same and this 0 turns into 1. So this is 1 bit flipping, right? But here these 2 bits are getting flipped. So this is not unit distance, right? Again here 1 bit is flipping, but the problem is that here in this case 2 bits are getting flipped. So how we can convert this coding into the gray code? We can write it like this: 0, 0, 0, 1, 1, 1 and 1, 0. Now you can see 1 bit flipping here, 1 bit flipping here and 1 bit flipping here. This is called as unit distance code or the gray code. So this gray code we use in the K-map representation. Here we will write 0, 0, 0, 1, 1, 1 and 1, 0. Similarly, for the 4 variable K-map, 0, 0, 0, 1, 1, 1 and 1, 0. 0, 0, 0, 1, 1, 1 and 1, 0. Correct? So now Generally, we solve the K-map for SOP form. What is SOP? Sum of products. We already know about sum of products. That is where we find the min terms. And when we talk about min terms, we say that if a variable is in the direct form, then its value is 1. And in the complement form, its value is 0. So, what is the value of this cell? This is 0, 0, 0. And decimal value is 0. Right? What is the value here? 0, 0, 1. The decimal value 1. Now here 0, 1, 1. This is 3. 0, 1, 0. This is 2. Right? Similarly, what will be the value here? 1, 0, 0. That is 4. 1, 0, 1. That is 5. 1, 1, 1. That is 7. And 1, 1, 0. That is 6. So, you have to remember this indexing of the K-map 0, 1, 2, 3, 4, 5, 6 and 7. Right. Similarly here 0, 0, 0, 0 that will be 0. 0, 0, 0, 1 that will be 1. So similarly 0, 1 here will be 2, here will be 3, 4, 5, 6 and 7. Then here 8, 9, 10 and 11, 12, 13, 14 and here will be 15. This is how we do the numbering of the K-map. Means these are the cell positions, right? And this number, this value will be called as the min term. Okay. Here the min term will be 0, 0, 1, 1, right? If A, B is 0, 0, how we will write it? That is A bar, B bar. If I say we need to fill the value of this cell, so what will be the value? Here A value is 0 and B is 1. So we will write A bar B, and here C and D both are 0. So it will be C bar and D bar. This will be the value, right? Similarly, if we need to fill the value of this 0, 1, that is A bar, B, C and D bar. As you can see from here, we are filling the value. This is how we fill the min terms in the K-map. I hope this is clear to you all. Now, there are some rules to be followed while representing the Boolean expression in K-map. First of all is no zeros are allowed. This means that we generally solve the K-map for sum of products. By default, we solve them for sum of product, and in sum of product, we place the cell values as 1. And in the in case of product of sum, we fill the cell values with the value 0. But in case of sum of product, we fill the values of K-map, we fill the cells of K-map with 1. Now, second point is group can be vertical and horizontal, but not diagonal. Now, here you can see in K-map, we generally do the grouping, right? How do we create the group? Like we can create some horizontal group, we can create some vertical group, but we cannot create this kind of diagonal group. Okay, this diagonal group is not allowed. Okay, now this cell, this cell, this cell, we cannot combine these three cells in the form of a diagonal group. This is not allowed. Okay. Overlapping is allowed. What is the meaning of this point? Let me just show you. Like we have created a 4 variable K-map, right? So in this, if we create a group of 4, this group of 4 can be overlapped with another group of 4. This group of 4 can be overlapped like this. Overlapping is allowed. Now, if we want to create a group of only 2 cells, then this overlapping is also allowed. Okay. Group should be as large as possible. The fourth point is that group should be as large as possible. First, we need to create a group of maximum. We can create a group of 16, then 8, then 4 and 2. So possibly if we are able to see a grouping of 8 consecutive cells together, then first of all we need to consider the grouping of 8. Although it can be formed in the group of 4, but we need to look for the maximum grouping first. And group must contain 2 raised to the power n cells. That means the grouping can be of a pair. Pair means 2 consecutive cells. The grouping can be of quad. Quad means 4 cells. Right? These 4 cells can be like this. These 4 cells can be like this vertical, this horizontal, 4, and even the corners also form the quad group. Okay. Octa means 8. So we have the grouping of, we can also have the grouping of 8. How we will have the grouping of 8? Now this can be the grouping of 8. This can be the grouping of 8. Okay, even the corners, this can also be the grouping of 8. In the vertical as well as in the horizontal direction, we have the group of 8. This grouping in K-map is very important. You need to form the correct groups, then only you can simplify the K-map. So let us solve few examples. Now here, first of all, we can see that f is a Boolean function comprising of 2 variables, and we need to solve it for sum of product. The submission sign denotes sum of products, and if we use the pi sign, that means we are talking about product of sum terms. So now, these 3 are the min terms values. Okay, so let us create a 3 variable K-map and then we will solve it. We write A here, B and C here. The A can have value 0 and 1. And here we need to put the gray code 0, 0, 0, 1, 1, 1 and 1, 0. Right. So as we know the indexing 0, 1, 2, 3, 4, 5, 6 and 7. So the first term is at first min term is at point 0. So this will be, so here we will insert 1. The next is here 1 and the next is 2. So here we have the 3 min terms. Now how do we do the grouping? As we can see, we clearly see we can form a pair here, right? This one pair is here, and now this is our group 1. And we can also join the corner ones to form another pair. This is group 2. So now we need to name it, we need to simplify it. So here you can see the value of A is 0 only, and the value of B and C. Value of A is 0 and the value of B and C is 0, 0 and 0, 1. So we will cancel out this because this is changing. This is not constant and B is constant. So A0 means we have A bar and B0 means we have B bar. So the group 1 will be A bar, B bar, right? We are doing the sum of product, so we will have the plus sign here. This is sum of product term, right? Another grouping for group 2 also we can see that the A variable is 0 and the BC are here BC is 0, 0 and here BC is 1, 0. So we will cancel B here and we will keep the C. So the pairing will be A bar, C bar. So the final answer of this question is A bar, B bar plus A bar, C bar. This is one product term, this is another product term, and we have the plus sign here. So this is sum of product terms. I hope this is clear to you all. Similarly, we can solve one more question for 3 variable K-map. Sorry, it is again okay, no, it is a 3 variable K-map, right? You can write A here, B and C here. 0, 1, 2, 3, 4, 5, 6 and 7. The value of A is 0, 1. Here we will write the gray code 0, 0, 0, 1, 1, 1 and 1, 0. So placing the minterms, 1 will be here, 2, 3 and 5. Now, as the rule says that we need to go for the maximum pairing first. So we can see that we can have a quad group here. We can clearly see we have a quad group here. So this will be our group 1. Another, we can see we can form a pair here, right? So this will be our group 2. Now talking about group 1, the value of A is 0, right? And the value of BC is 0, 0, 0, 1, 1 and 1. As you can see, not both the variables are constant, so we need to cancel out both the variables. So the answer will be A bar. Plus, coming up to group 2, here we can see the value of A is 0, 1 and BC is 0, 1, right? Only we have only 0, 1. A is not constant, so what we will write here, B is 0, that is B bar and C, because we know that in sum of product form, if a variable is in direct form, it is written as 1 and its complemented form is written as 0. So the answer will be A bar plus B bar C. Coming up to next, 4 variable K map. This is f of A, B, C and D. This will be interesting to solve. We can write A, B here and C, D here. 0, 1, 2, 3. Remember this indexing. 4, 5, 6 and 7, 8, 9, 10 and 11, 12, 13, 14 and 15. So 0, 1 and then 4. Okay, I'm just looking at these minterms and filling the value 1 over the places. Then 5, then 8, 9, we have 12 and we have 13. Okay, now you can clearly see here we have the grouping of 8 here, right? So value of 0, the AB will be 0, 0, 0, 1, 1, 1 and 1, 0. Here 0, 0 and 0, 1, right? So the grouping of 8 octa group is forming here. Now the value of AB, we can see that not constant, so we will cancel out AB. Okay. Now CD have the value. Okay. And then we have C bar and D. Sorry, C bar, D bar, C plus C bar, D. So this will be the answer for our 4 variable K map. These are few practice questions that you can follow. These are the references from where we have created this content. So if you have any doubt, queries, you can comment in the comment section box. Thank you.